You're watching PowerNation.
Today on Engine Power, we team up with the UNOH Motorsports program to build them a brand new, class-specific, race-winning dirt track engine. Hey, hey, welcome to Engine Power.
Morning,
Good to
Frankie.
see you again. Morning.
Good seeing you.
Good to see you,
Good to
Frankie.
see you, Brett.
Mr. Higgins,
Nash,
always a pleasure.
good to see you.
Good to
Brett,
see you, Pat.
Nash,
Good to see you. How you doing?
guys made it okay? Everything's good?
Very good.
Awesome. Well, we have a ton of parts laid out, and we're going to have a really great engine by the end, so we'll show you what we got.
Okay. Just come over here. Let's look at some parts.
Yeah. Today on Engine Power, we have a really special build planned that's going to be really cool, and I'm actually very excited about it because we are building an engine for the UNOH Motorsports team for one of their dirt track stock cars. This is a great program that I went through, so we're pretty happy to give back. And the base of our build is going to be this World Products Motown small block Chevy block, so this is going to be the heart of your guys' build.
That sounds awesome, Frankie.
So tell me a little bit more about the block.
So this one is finished at 4,155 bore. We also have a 3,750 stroke crank, so it's going to be 406 cubic inches. And this is a billet 4-bolt blade cap. It's a really, really nice block.
Sounds like a good package.
Yeah, and it should be pretty serviceable for you guys too. We have, standard size lifters, standard cams, so parts are easy to get. If you need to, eventually service this thing, get parts down the road, it should be relatively easy to, take it apart and find off-the-shelf parts for it.
Awesome.
I think this is going to be a great foundation for the build, and we've worked with a bunch of companies to get a ton of great parts to go inside of it.
Now, we need a lot of hardcore parts to stand up to the rigors of the demands of the application. So we're going to start out with a Cali's Compstar 3750 stroke 4340 forged crank. Along with that, we have a set of Molly Power Pack pistons. These have a 1-inch compression height, and they have the dome that works with our combustion chamber. But that goes with all of our rods that we have for this build.
And they have a 6 and 125 center to center length.
Correct, you can tell you studied. They have a 927 pin with a bushed end. To go along with that, we have a custom ground comp solid roller. It's 900 base circle, and we'll go over the specs for that later. And that goes with a set of Sportsman lifters from comp as well. Rounding it out, we have a set of Total Seal gas-ported rings that's going to work great in this application.
The University of Northwestern Ohio, or UNOH, houses one of the country's best vocational programs in Lima, Ohio, and offers degrees in fields like automotive technology, diesel, HVAC, and our favorite, high-performance motorsports. They push hands-on education to give their students real-life experience in their field and have over 20 student-run clubs and their own motorsports team to give students as much knowledge as possible before they graduate.
The motorsports team at the university is an extracurricular activity. On the motorsports team, the students do absolutely everything. They build the cars, they build all the engines. The stock car class has gone through a lot of rules transitions in the most recent years. They opened the rule up to allow 4-barrel carburetors on those, which has totally changed the whole build aspect of the engine.
The cars are a G-body front clip, and they have to have a cast iron block, cast iron head engine with now a 4-barrel carburetor.
Wow, that's a huge change to go from a 2-barrel to a 4-barrel setup. That's kind of the idea of building guys a fresh engine so we can change the combination and take advantage of that. But tell me about the other rules of the class because they're kind of restrictive, right?
Yeah, we do have some other rules in our class. In our class, we are required to run cast iron heads, stock valve angle, so that's 23 degrees. We're also required to run stock ignition style and mechanical fuel pumps.
Okay, so yeah, for heads, that is kind of a restrictive piece because you're only limited on options for what you can get for cast iron, but we got you guys a set of Dart Iron Eagle 230s. This is a new old stock head. They actually don't make these anymore, but it's basically the biggest cast iron head you can get. These flow 300 CFM and should be plenty to make the power that we're trying to make for this class.
We have some really good rods. We have some great pistons, a nice looking camshaft. It's super nice stuff.
All right, well, we got a ton of great parts. I think it's time to stop talking and time to start working.
Awesome, let's go.
Heck yeah.
Up next, the students put together some high-tech parts to build a race-ready short block. Brett and Nash have a ton of hands-on experience with UNOH, and they jumped right into the build process. Starting out, they torqued up the main bearings and set up a dial board gauge to measure main bearing clearance and set each of the mains between 26 and 31 10,000ths of an inch.
I got involved in the race team by seeing the emails that Coach sent out. It's everything I hoped for. I've been learning so much. It's really a great opportunity for anybody who wants to learn.
It's all about teamwork. I've learned a whole lot about working with other people, and on the team we rely on everybody. That's the greatest part of UNOH, is you just get to know everybody, and I've made tons of friends and met lots of cool people.
Nothing that makes me more proud when a student graduates from the university that was a member of the motorsports team and has found a career path in what they desire, and they come back and tell me how successful they've been.
The students measured the rod bearing clearance in the same process as the mains, torquing the rod bolts to achieve between 53 and 57 10,000ths of an inch stretch, and setting up the rod bearing clearances between 22 and 25 10,000ths of an inch. With all the main clearances set, the crankshaft can be laid into the main saddles, main caps installed, and the main fasteners torqued to 70 pound-feet.
Our Comp custom ground billet steel solid roller camshaft uses Comp's new LNW low shock technology lobes with durations at 50 thousandths lift of 269 degrees on the intake and 283 degrees on the exhaust. They are set on a 109 degree lobe separation angle, and net lift at the valve is 681 thousandths on the intake and exhaust with a 1.5 ratio rocker arm. We also utilized a 4-7 firing order swap, so the firing order is 1873-6542. For this build, we are using a Jessel belt drive timing set for ultimate durability and accuracy in cam timing. The timing cover is sealed on and cinched down with ARP studs, followed by the cam adapter and the lower crank pulley. The upper pulley is slid on with the groove timing belt, and the cam pulley bolt is torqued in reverse to 70 pound-feet.
So coming to the race team, I was just an open book. I wanted to learn, I wanted to get hands-on. I think it's kind of funny that I knew nothing and now I'm the head of engines.
The thing I love about working on engines and building engines is just the science behind everything, and how you can take a bunch of metal pieces and pretty much put them together and pump air, fuel, and spark through them, and they run and sound good.
The camshaft and valve vents determine when and how efficiently the air enters and exits the engine, and is based off of track data from other race engines. So the students degreed the cam end to have it 6 degrees advanced.
121 plus 85?
103.
103 centerline, awesome, that's great.
This engine will utilize a fluid damper, viscous style harmonic damper that will diminish the widest range of dynamic harmonic frequencies and won't have to be rebuilt after every dirt racing season like an elastomer style damper.
We're putting the rods and the pistons together. Because they are non-press fit, they require clips. So we're just lubing them up, pressing them in, ensuring that they're the right direction.
Now for our dirt track engine, it's going to be in an abusive environment constantly, so we wanted a trick ring pack, and we reached out to the guys at Total Seal to get one to fill our pistons. So what we have is a 1mm, 1mm, 2mm ring pack with a standard tension oil ring, a Napier style second ring, and the trick piece of this is the AP 440B stainless steel top ring, and this has lateral gas ports machined into the top of the ring. What that does is allow combustion pressure to get behind the ring and force it out against the wall, improving sealing. Now these also have a C33 PVD face coating, and what that does is helps to keep dirt from embedding in the ring, which is probably going to be really, really helpful in a dirt track environment. Now we do have gas ports in our piston, and you're probably wondering, can you run gas ports in the piston and the ring? And the answer is yes, 100%. They actually work together, and it works awesome for helping to seal the cylinder. So we're going to get these installed and get them lubed up, and then start putting pistons in our block.
Thank you, sir. Yep, got it.
The rod and piston assemblies are installed using an ARP tapered ring compressor, and Nash gently pushes them into the block one by one while Brett temporarily tightens up the rod caps.
How's it going, guys?
Going great, we just got the last piston in and rotating assembly's all finished.
All right, ready to torque off the bottom end and stuff?
Yes, sir.
Absolutely.
Frankie, they doing a good job?
Hey, they're kicking butt. They're plowing through this thing. We've got the short block basically done, so once we get those rods torqued, I think we'll get the bottom end sealed up and go up top.
That's awesome. Really good.
Coming up, we finish up UNOH's newest dirt track racing engine and get it ready for the dyno.
In order to get the bottom end sealed up on the newest UNOH dirt track bullet, a Melling shark tooth high volume pump and ARP oil pump drive shaft are dropped in, and the ARP oil pump stud is torqued to 65 pound-feet. The edges of the pan receive some RTV, and a one-piece oil pan gasket drops on, followed by this Moroso 7-quart oil pan from Summit Racing that has kickouts, baffles, and a crank scraper.
All right, guys, looking good. Got the studs out of the box. If you want to get them prepped, we'll be putting these heads on.
Awesome.
Sounds good.
So remember, for heads, we have a set of Dart Iron Eagle 230s. These are a little bit hard to find, but we were able to find a bare new old stock set. So we have outfitted them with some valve train from Summit Racing equipment. Namely, we have a 2080 intake valve and a 1600 exhaust valve. For springs, we have gone ahead with a pack 1243X spring pack that we have set up for 211 pounds of seat and 565 pounds of open at our lift, paired with their tire retainers and a set of their keepers. Now, to get the compression ratio that we wanted, we actually dropped these off to our favorite automotive machine shop here in Nashville, Shacklet Automotive Machine, and he flat milled the heads for us down to a 65.2 cc combustion chamber. Paired with our 4165 bore 27 thousandths compressed thickness gaskets, and Shacklet also square decked the block to 9 inches for us, we have a 13.63 to 1 static compression ratio, so that's going to be great for making power. They'll get those studs prepped, and we'll get these babies bolted on pretty soon. The heads are being held down by a set of ARP 7/16 head studs, which do not need any sealer since the head bolt holes are blind in this aftermarket block. They are torqued in 3 stages to 80 pound-feet with ARP Ultra Torque.
Starting to really look like an engine now.
Looks good. I like it.
Yeah.
Just take your time.
The Comp Sportsman Series solid roller bush lifters were pre-soaked in oil and can be slid into their lifter bores. The rest of the valve train consists of Jessel shaft rocker stands, Comp 3/8 diameter 80 thousandths wall 8-inch long push rods, and Jessel 1.5 ratio Sportsman shaft rockers. The rockers are installed in the firing order at TDC compression stroke and torqued to 26 pound-feet, then cold lash is set at 16 thousandths.
While those guys finish up the lash on this engine, the next thing we're going to be installing is the intake manifold. And to cinch down this Edelbrock Victor 2 intake manifold, we're going to be using one of ARP's stainless steel intake manifold bolt kits. The great thing about these is that they are fully stainless, and this is a dirt car, so this thing is going to be abused, it's going to be raced, it's going to get muddy, it's going to get dirty, and it's going to get pressure washed probably every week during race season. So these are not only going to be strong enough to do what we need as far as clamp load, but they're also not going to corrode when they are exposed to the elements like you would find on a regular steel fastener. Even if it has a coating on it, as soon as you break that coating with a wrench or a socket, it's going to let corrosion get in there and start rusting. So these will not do that. And we also have a bunch of matching kits for the rest of the engine, everything from motor mount bolts to fuel pump bolts, so that we have that same quality and that same look all the way throughout the engine. Well, it looks like those guys are done, so we'll get this baby on. All of the ARP stainless fasteners have 180,000 PSI of tensile strength, which is way higher than even a grade 8 you'd find at the hardware store, which are normally about 150,000. And ARP includes cool features in their kits, like these front 4 intake manifold bolts actually have a smaller head radius to clear the coolant ports on the front of the intake. So that's super handy getting them in. You don't have to modify your intake, you can just drop them in and go. We got something cool for your valve covers though, just so everybody knows who built the engine.
Man,
Awesome, man, they look great.
Thank you.
Yeah, go ahead, get them on and we'll keep going. With the crankcase sealed up, we can install a critical system for finishing a race, the front accessory drive. We are using a Jones Racing front drive with a high flow water pump, power steering pump, and 1-wire alternator that will run the car's various systems and can turn 8,000 RPM consistently. As the rules require a mechanical fuel pump, we chose a Holley 170 gallon per hour unit with -8 AN outlets to feed our new carburetor.
Looking pretty good, guys.
Thank you.
Now with that new roll that we're building this engine specifically for, look at what we get to put on it.
Yeah, it looks great.
This is a quick fuel 1050 CFM 4-barrel carburetor, right? So this is going to give you an extra 2 barrels of extra horsepower. So can't wait to get this thing, get it on, get it bolted on. Let's make some noise in the dyno.
Awesome, looks great.
Excellent. Up next, we put this 406 to the ultimate test in the dyno cell.
We got our QFT 1050 bolted down with no spacer for now, and then we were able to get the engine into the dyno room, get a Wix filter on it, and we actually went ahead and got most of the engine ready. We have a lot of the lines made, like water lines and fuel lines, and got pretty much everything we could bolted to the engine, including a set of Schoenfeld dirt track headers we got from Summit Racing Equipment. These are actually the headers they're going to be running in the car. We know they fit the chassis. They have a 1 3/4 to 1 7/8 to 2-inch triple step with a 3.5-inch collector, and miraculously they actually fit the dyno, so we're going to be able to use these and get an accurate number. The next thing we need to do is prime the engine with oil, and to do that we're going to be filling it with 7 quarts of Schaefer's Supreme 7000 series racing oil. This is a 15 W40. We wanted a quality racing oil because we're not only going to be beating on it here on the engine dyno, but students are going to be racing this car. They're going to be running it on the track, and we wanted a quality oil for the engine there as well. So this has great resistance to thermal breakdown. It has abrasion resistance. It has wear resistance, so that way we can protect all those nice parts that we just put in. So we're going to get 7 quarts of this in and get some oil pressure in this bad boy.
This thing has excellent oil pressure, 77 without it running.
Wow, that's crazy. That's good.
Our class dictates we have a stock style ignition. So for our Chevrolet, that means an HEI. We went ahead and picked up an MSD Pro Billet HEI distributor and already locked out the vents on it and installed a bronze gear for our billet camshaft. Now we will put on the cap and wires and start making some power. We made a custom set of 4/7 swap MSD superconductor wires for this build, and they are feeding a set of NGK R5673 plugs with a heat range of 7. All the UNOH cars use Sunoco 112 racing fuel, so the students brought several pails with them, and after filling up our fuel tank, we are ready to go.
All right, so we got the engine on down. Are you guys ready?
Yeah.
All right.
Yes, sir.
Here we go. This is where all the hard work starts to pay off.
Sounds good.
Sounds real good.
Immediate light.
Yep.
Nice and throaty.
62 pounds of oil pressure at idle.
First thing we're gonna do is we're just gonna get some heat in it, right?
Yep.
It's very, very tempting to just start blasting on this thing, right? Because it's got a bunch of good parts in it,
Yep.
but we wanna make sure everything is doing what it's supposed to. Our pressures look good, our temperatures look good, and most importantly, our lash looks good, so.
Yep. With the engine at full operating temp, we can shut it down, and the students will check each valve's lash setting individually, making sure none have changed drastically, which could indicate a problem. Then they will adjust them, if needed, to our hot lash setting of 16 thousandths.
All right, so how close was the lash? It looked like it was pretty good.
Yeah, all of them were pretty close. There were a couple that were a little tight, but
Okay.
across the board, it all looked really good.
All right, I think everything looks good, so let's put it at 300 a second and raise the RPM. We'll go from 4,500 to 7,000, because this thing looks like it should peak. Before that, we set the cam up advanced, so.
That's more representative of where it's gonna run in the car as well,
Yeah.
so. Let her eat. That's not bad.
Not bad.
That's not bad at all.
For
right there.
relatively not a lot of
Yeah.
timing. Okay. Not
I'm
bad.
gonna call that 500 pound-feet.
Yeah, 499.9
Yeah, yeah.
and 584.9 horsepower.
In order to fully tune the engine to race trim, we'll spend several hours with the students making several dyno runs and incrementally adjusting the ignition timing and fueling to safely gain as much power as we can with their new power plant. We landed on 36 degrees of timing with 84 primary jets, 91 secondary jets, and 28 thousandths high-speed air bleeds.
Yeah, all right, we'll see what 36 does here. It's like,
Oh, so close.
snap.
We're so close.
598.2 horsepower and 503.7 pound-feet.
Baby.
I mean, that's
That's,
dangerously close to 600.
Well,
That's it.
cut her off and Only thing I want to do now, let's put a spacer on it just to see if it does something. Spacers do one of three things. They help, hurt, or it stays the same.
We're going to find out.
It'll do one of those three things.
All right, let's go do it. Based off previous combinations, we are jumping straight to the big dog, a Wilson 2-inch 4-hole tapered spacer to try and squeeze a bit more out of this dirt track power plant. All right, we're gonna see what happens right now.
Awesome.
Ready? Here we go. Hold on to your pants. Heck yeah.
That's awesome.
601.9.
And 511 pound-feet. I saw that torque swing and I was like, it's gonna do it.
That is awesome
Wow.
right there. Cool.
Yep, peak horsepower at 6,800. Let's see, peak torque at 5,100. That's a good spread. What do you guys think? You built this engine, you're gonna race this engine, and we got to dyno this engine. How cool is that?
No, it's awesome, man.
Yeah, that's really cool.
Nice job. Nice job up there.
Great supervision.
That's a supervision right there, that guy. And like we say,
Great success. For more high-power engine builds like this one, you can find engine power on PowerNation.